I'm Lisa Gittner. I'm from political science and I'm from the Department of Public Health at HSC. I've got a joint appointment. I'm going to talk to you a little bit about obesity today. And obesity is a problem that everybody should really be worrying about. Do you realize that 1/3 of the entire US population is either overweight or obese? That includes children, teenagers, and adults. That's pretty huge. It costs $190 billion a year for problems with obesity, related to obesity for our healthcare system. That's enormous. You're going to say, oh, well, it's just a US kind of thing. Well, no, it isn't. By 2030, conservative projections show that half the world's population will either be overweight or obese. Those are pretty enormous numbers. So the way I look at obesity, I look at obesity a little bit differently. I'm not looking at adult obesity. I actually have a very specific niche, and I look at infant obesity. And it's really interesting because infant obesity is very different, and you're all going to say, oh, no, there's no such thing as a fat baby. Well, I'm here to disagree. Yes, there is. There is such a thing as a fat baby, and we can actually look at how babies grow in the first year of life. And with 97% specificity and 95% sensitivity, I can tell you if that baby is going to be obese or overweight by the time they hit school age. Really kind of scary. And the other thing we've discovered is we've discovered morbid obesity in infants. And so that is really scary. So, when you see those pictures of chubby cheek babies and everything, and you say, oh, well, that's just baby fat, they'll grow out of it. No, they aren't. They are set up on a growth pattern from infancy to lifetime obesity. So the interesting thing, though, about infant obesity is, well, we think of obesity as sloth or whatever, adult behaviors, and, they're obese because they just can't put down the Big Macs. Well, infants aren't like that, are they? Infants truly are energy in, energy out. Calories in, calories out, and then they grow. And so what is going on that are making all these infants obese? So I work with another group of people, and we do all kinds of health modeling, health service modeling and everything. And we have this big exposome data set, and we model all different kinds of health things, and we're looking at connectedness of factors in different, basically health service kind of factors, healthcare kind of factors, individual factors. We model and say, can we figure out what's connected to these different kind of health outcomes? So I said, for giggles, let's put in obesity, both childhood and adult obesity. Let's put it into this exposome, and what we do is we use basically computational biology techniques and graph analysis, and we look for connections. We've got about 600 variables in this data set. We look for connections, and we put it in, and all of a sudden it was like, wow, the counties in the U.S. with the top 25% counties in the U.S., top 25% obesity counties, and the bottom 25% obesity counties in the U.S., they looked very, very different. They were connected to different kinds of factors and different kinds of things. But what came out was that climate and pollution happen to be connections. So I say climate and pollution. Well, pollution kind of makes sense because when you have endocrine disruptors, yes, in early life, they disrupt phenotype development, plasticity, all that good kind of stuff. So, pollution makes sense. But climate, and the climate we had in there was only precipitation and heat index. And so it was like, well, we need to take this just a bit further. So I got out my trusty maximum entropy program and said, okay, I'm going to take species distribution a little bit differently. And the species I'm going to look for is I'm going to call species obesity. And from there, I'm going to train it. In 2000, I'm going to use all of this data that I have on climate, which was not a whole heck of a lot. It was basically sunlight, maximum, minimum temperatures, precipitation, and that was about it. And I'm going to just plot that in 2000, and I'm going to plot it in with the obesity rates, and I'm going to train this model, and then I'm going to say predict obesity in 2009. Well, what did I get? Well, I got something very interesting. I got this graph, and if you look, the red, that is the highest rates of obesity. And so this was predicting obesity with just climate factors here in the United States. And so I said, oh, that's really interesting, and it's also really scary because this is the actual obesity rate in the United States. So when you look at these two together, predicting from only climate variables and predicting from an actual, my gosh, these maps look alike, don't they? They look a lot alike. So from there, it was like, wow, this is really kind of scary. So how can I be predicting this much obesity from only climate factors? This doesn't make any sense. So it was like, I better go back to the models, and I better control for absolutely everything we think contributes to obesity. All the social demographic stuff, all the income stuff, all the social deprivation, all the different comorbidities. So I did. And we ran this model 6, 7, 8 different times. We ran it straight. We ran a regression. We ran a logit. We logged it. We lagged it. We did absolutely everything. And the scary part of it was that these 5 climate factors, they predicted in every single model between 25 and 40% of the obesity rate. So it's like, now what? And this is where we are now. This article is out, for review, for publication, and we're writing a grant. We're actually writing a grant, pulling everybody together. The grant goes in June, about looking at, this was just a snapshot, a cross-sectional snapshot. So now I want to build a model of obesity. And I want to look and see all these multimodal factors, not only spatially, but I want to look temporally, because what has happened over the last 40 years. So that's where we are. Thank you. Questions?
Can you say again, what data set did you use to calibrate the model?
What data set we used, we had an exposome data set with some climate factors that we pulled down. We didn't have a lot. And this exposome data set, we were actually funded by NIH to build an exposome data, a public health exposome data set. And so what we got, the few climate factors we had, we got from NASA.
Okay, and this included information about obesity up through what year?
The obesity rates we got were from the CDC, the actual obesity rates, epidemiologic obesity rates. And we calibrated it with the year 2000. 2000 obesity rates, 2000 climate. And then we took the climate from 2009, and we said, tell us where the distribution of obesity would be. And that's what we got.
Okay, but the time correlation between the climatological predictors and the obesity predictors would be high. I mean, the data that you're predicting would be highly correlated with the data you use to calibrate the model.
Well, we agree. That's why we want to do a longer time period. We don't have any funds to be able to do it. We're stuck at 10 years right now. And they funded us again. NIH has funded us. Jenny and Bufang are actually on this little pilot study. They funded us to do this for infant mortality right now. But again, only over 10 years. That's the problem. NIH kind of looks in these 10-year kind of chunks. So we're hoping that we can convince them to let us look over 40 years, because that's where the big obesity epidemic has started.
I get a quick question. So your data for obesity is it accumulated over?
The data for obesity is the CDC epidemiologic data.
Right, but it's an accumulation of several years.
They have they have a snapshot for each year, and then what they do is by decades, they then accumulate it by decade. But they do have each year individually.
So you have obesity data and you have climate data of the same year.
Of the same year.
And would you not expect a lag?
I would expect a lag. And that's what I thought we were going to have a lag. And we didn't have a lag. So we're not sure. That's why we need to model. I mean, I would expect that we probably should have a 5 to 10 year lag, because you have plasticity. And so you would expect, basically, if you think about heat stress, especially heat stress in mammals, you would expect that the fetus, they would be the ones that were stressed, and then you would see that develop in their life course. So you would expect that life course lag, at least 5 to 10 years, maybe longer, maybe a generational kind of lag. That's what you would expect. But we don't have the funding to do that yet. And the problem is the obesity data sets, they only go back 40 years, and then they really start fragmenting. So we've got a problem there. And what you have to do then with obesity data sets older than 40 years, you have like all these different school children data sets were collected in all different kinds of ways, and that's a problem.
Can you or Jenny speculate a little more on causal connections?
Well, obesity is very multimodal. And so we don't have a really good model of obesity. We really don't know. And when you start thinking about plasticity and epigenetics and phenotype development, I'm speculating that that's what's going on. That part of the obesity epidemic is going on because of phenotype development, because of plasticity. And some of the landmark studies like Barker studies, where he looked at schizophrenia and depression after the Dutch famine, that was plasticity and phenotype development. I'm suspecting we're seeing the same kinds of things.
Where do you think diet and exercise figures in? Either
Well, for babies, it doesn't.
Yeah, but cost of food, or the inhibition to do much exercise because of heat and humidity and things like that.
Well, it's really interesting. They're doing some studies on brown fat, and we thought that brown fat was only in infants and then it went away in adulthood. Well, we're finding that brown fat does not go away in adulthood in many mammalian species. And so they're starting to think, well, and there are a few studies out in the last couple of months that adults, humans, still have brown fat. So we're wondering if it has to do with that we're changing the phenotype of that and it's changing how we metabolize. But we're not sure. That's so preliminary at this point.
Are there data on air conditioning?
There is data on air conditioning. Air conditioning is really interesting. They started collecting data on air conditioning in the 1960s. And it's really interesting. You would think everybody's air conditioned, right? And by the 1980s, everybody would be air conditioned. Well, in this belt down here, where you see the bright colors, up until 1995, only 65% of those people were air conditioned. And when I say air conditioning, I don't mean central air conditioning, that there was an air conditioning unit in one window in some of the houses. And even up from the census data from 2010, they're still hovering, they're still hovering with 60 to 70% air conditioning. So we know air conditioning has a play, but we have that to have.
All right, so we'll stop it there. Thank you for the great questions. Thank you.